Our next set of transformations is brought about by multiplying, or dividing, which is multiplying inside out, I guess. Okay, so some of these are simple ones. They are reflections around either the vertical or horizontal axis, and the others are a little bit more complicated, where we zoom in or zoom out on something. That's called scaling, when we multiply it one way or another. Okay, so the first one has to do with multiplying by 1. Or, no, that wouldn't change it at all, would it? What I mean to say is multiplying by -1. So, since it's a vertical change, what I'm going to do is take a graph, whatever it might be, and turn it upside down. So, sort of like that. Well, in order to produce that effect, if we start with y is equal to f of x, then if I turn everything, if I multiply the entire thing by -1, I will be able to turn it upside down. Let's take a look at this effect in Desmos. So, I start with y is equal to x squared, and then I multiply outside the parentheses here for negative outside the parentheses x squared, and this red graph is the result. It turns the entire parabola upside down. So let's take a look at this numerically. I have my x values, so x and then y is equal to x squared. So let's say -2, -1, 0, 1, 2. -2 squared is 4, 1, 0, 1, 4, and so on. If y is equal to -x squared, then I take all of these y values and multiply them by -1. And so I'm just going to scribble through these so that we can see all of my y values, and only my y values, are transformed. And that's what we've done here. All the x values stay the same, the y values change. And this works with all kinds of functions, not just x squared. Let's look at square root of x. We multiply that by -1 and turn it upside down, like so. Multiply by -1, change all the y values from positive to negative, and if we had any negative y values, we would be changing those from negative to positive. Okay. So, observe also that what causes this vertical reflection is a multiplier outside the parentheses. Okay, so it won't be very surprising in light of what we've already looked at that to make a horizontal reflection over the vertical axis, we are going to multiply inside the parentheses. So if our first y equals is f of x, then let's let our second y equals be f of -x. Now, if we started with a parabola, we wouldn't even be able to see what happened, because the parabola, after all, when you reflect it horizontally, you get the same thing you started with. So we don't want that. We'll have to choose something else a little bit more distinctive when we translate it. Reflect it, I mean to say. Okay, so there we have a square root function. And if this is y is equal to the square root of x, then the big question is, what is y equal to the square root of negative x? That's inside the parentheses, so to speak. I'm thinking of a container like a square root or an absolute value as being, in effect, the same as parentheses. Man, is that a great drawing. Okay, so again, let's not make a table. Let's go to Desmos and see the effect. Now we see here y is equal to the square root of x, and inside the parentheses now, there. Isn't that perfect? So the horizontal shift is produced by having the -1 multiplier inside the parentheses.